Hello, I'm Jeffrey van Gogh. I'm a tech lead on Android Studio, and I'm there responsible for programming languages and compilers.
And I'm Hadi, developer advocate at JetBrains.
Okay, so it's been 2 years since Google announced Kotlin support for Android, and yesterday we announced that Google is going Kotlin first, so we figured we'd give you some background on this. And so, of course, we didn't start 2 years ago. We took quite some time to get things ready for Kotlin on Android, and really started about 3.5 years ago. It was a bunch of us language geeks at Google, Tor Norby, Roman Guy, me, starting to play with Kotlin and like, hey, this is actually quite nice. And of course, Android Studio is based on IntelliJ, and IntelliJ started using Kotlin in its own code base, so we started to see more and more Kotlin being used in Android Studio. And at the same time, we were getting a lot of customer feedback from our customer advisory board, surveys, and ad hoc discussions at conferences like these, that people really like Kotlin, and they really would like Google to support it, because their companies would not adopt Kotlin otherwise. Of course, taking on a new language like that is a big task, so we had to convince our directors that this was something worth investing in. The best way we found to do this was to just get our directors to code for a couple days in Kotlin, and after that they were sold. So a couple months before I/O 2017, we decided to go for it. And this meant so many meetings to set this all up. If you think as a tech lead or manager you don't have enough time for coding anymore, try setting up a foundation. So we got this all ready. One day before before Google I/O 2017, there was this big thread on Android dev subreddit, how Google was never going to embrace Kotlin. Of course, we knew what was going to happen, but it was so hard to not reply to that thread. So yeah, 2 years ago, Steph was on stage announcing Kotlin support. I think it was the loudest applause of the developer keynote. It was amazing. Of course, we all knew at both JetBrains and Google that that meant that we had a lot of work ahead of us to make sure that Kotlin worked well for Android and in general. And so today we want to show some of the work we have done over the last 2 years. Hadi will talk about what happened to Kotlin in the last 2 years, and then I'll take it back and I'll talk about what we did on the Android side.
Thank you. So to start, I want to just mention about the Kotlin Foundation, which, if you remember, when Google announced official support 2 years ago for Kotlin, we also briefly mentioned that we'll be forming a foundation, which was created by JetBrains and Google to protect, promote, and advance the language Kotlin. The foundation is governed by a board of directors, which are 2 representatives of JetBrains, 2 of Google, and 1 independent member. And to give you a little bit of idea on what the scope of the foundation is, one of the jobs is to appoint a language lead designer, which currently, of course, is Andrei Breslav. And there's a language committee that controls breaking changes. And it's very important here to understand that this is limited in terms of scope. So it is only about breaking changes. Kotlin continues to be developed as it is now in the open on GitHub. We still have the Keep, which is a Kotlin evolution enhancement process. But the language committee is mostly around controlling the breaking changes that might happen into the language. And also there's a trademark subcommittee that is about protecting the trademark of Kotlin and working with the community to help promote Kotlin and use Kotlin in a fair way. And if you want to find out more about the foundation, you can go to the Kotlin Lang website, where you'll have more information as well as details about how you can use Kotlin and trademarks, etc. And with that, let's switch over to the demo, and I'm going to show you some things with the language. This is where I'm using someone else's machine. Let's see how this goes. I think the ID is correct, yes. OK. So I'll show you some things around the language. So probably the most fundamental, most important thing that we have done, which has taken a very, very long time, if you're familiar with writing a Kotlin application, you have your main entry point. So we've actually now made that so you don't have parameters. OK? So that's it. Thank you. Jeffrey, you want to? No. We took 2 years. No. So we'll start with some small things we've done with the language itself. So for instance, one of the things with the when statements is that often you have to capture the value of a variable, and then you have to examine that variable, and you're only using that inside your actual when statement. So we've made this a little bit nicer in that you can essentially declare the variable inside the when statement itself, so you don't have to have it reference outside of the scope. And this gives you the semanticness in your language so that people understand that this is actually limited to just the conditional. But let's talk about a little bit more some nice features that we've introduced. Not that those weren't nice, I'm just saying nicer features that we've introduced. So let's say that I have, for instance, an application, and I want to create a class, okay? And I'm going to create my class, and it's going to be called the microservice API. Now, so I can create an instance of my microservice API, and I'll say microservice API. Here we go. Now, the thing is, I don't know if this microservice thing is going to last. It might just be a fad. So what I want to do is tell people that are using this that this is kind of like an experimental feature. So what we can do is we can actually create an annotation class. And I can say, for example, this is a new API. And then annotate that annotation class with this other class called experimental. And now I can use that new experimental annotation that I have created on anything that I consider experimental in my API. So I could add this new API here, and as soon as I do that, notice that this is going red. So it's giving me a compiler error, right? It's saying that you cannot use this because this is an experimental feature. If we hover over, it's saying that it's experimental. And in fact, we can change that. We can say that instead of it being an error, we can actually define it as the warning. Right? So here it could be a warning, and it's just now going to show up as a warning. So in order to use this, the developer has to essentially opt in to this feature. So what I could do is hit Alt-Enter, and now that adds the new API to my function call. So anywhere where I'm using this, it is saying that this is an experimental feature. This gives people idea into you can now create APIs that could be experimental and kind of like, I'm not going to guarantee anything. If tomorrow we want to change something, it's OK. You had the warning. You did hit Alt-Enter. I saw you hit Alt-Enter. It's OK. It's your own fault. And one of the things that we've actually done with this is we've introduced this concept of contracts. So if you're familiar with a little bit code contracts, we've introduced this as an experimental feature in Kotlin as well. So let's say that I have some function that is like, for example, print length. And this is going to take a string that is nullable, and then it's going to do if string is not null, I'm going to do print line length. Now this works, and it's done a smart cast to a string, a not nullable string, because it detects that I've already found out that this is not nullable, so I can do this smart cast. But if I were to take this, and instead of doing not null, I do something like not null, and I go ahead and create my function. So let's say I create my function that is a string and not null. That's going to return a Boolean. And then I say return this is not null. You see that it doesn't have that effect, because the compiler doesn't guarantee that that is actually not nullable. So it would be really nice to kind of tell the compiler that this function complies with a certain contract. And you could do this in Kotlin by defining using the contract lambda, the contract function, which is contract. And I can say that, let's import it, and I can say returns true implies that this at not null is not null. OK? Now, this gives an error. Ignore it. No, I'm joking. The reason that this gives an error is because this, as I mentioned, is an experimental feature. And there's two ways. I showed you the first one. You could add the annotation. But if you add the annotation, that doesn't propagate. So if something is using that API, that also has to add the annotation. You can add the propagating annotation to this, which is this format, and now I don't have to do that. And as soon as I add that, notice that this now automatically again casts to a string that is not nullable. Okay? So this allows you to actually create contracts and say that your function matches, your arguments to your function match certain conditions, and that basically is guaranteeing you a certain level of code correctness in your actual code. So what else have we been working on? Well, we've done this thing called serialization, which is a serialization library which is multi-platform, in that it's targeting JVM, JavaScript, Kotlin native, iOS, macOS, Linux, Windows, embedded. I think I mentioned everything under the sun. And this is a multi-platform library that doesn't require any kind of reflection. And it's part of some of the offerings that we're doing as part of like the language and the ecosystem around it. So here you can see that I have a class, a typical data class, and I've added this serializable annotation to it, which is part of the Kotlin serialization library. And then I have a bunch of, I have a customer, and I have a customer list of customers. So I could do something like print line, and then here I'm going to do JSON stringify customers, and indicate the serializer I want to use, and then pass in the actual customer. And I could do exactly the same thing for a list of customers. So I could do list here, and then pass in the list of customers. And if I were to run this, what this is basically going to do is output that data class in JSON. And we have support for JSON, we have support for protobuf, and other things are in the works. And we can obviously do the reverse as well. So I could say, for example, let's say that I have some JSON here. So let's go ahead and create some JSON. Edit. So we'll do ID equals 1, and then name equals me, and then email equals you@me.com. I'm so creative. And now I can do print line. And in this case, I'm going to do JSON parse, pass in again the serializer, and then the actual JSON that I want to pass in. And what this will do is essentially create the actual data class object for me in reverse. And you can see that it also has support for, it creates the data object for me in reverse. What did I do? Email, name, email. Field source is required. No, it's not. No, that should actually, right, anyway, so that was working. That's Jeffrey, he did something. I really like when people clap. So, I don't know what's happening there, but that's the good thing about live demos. I want to make sure that something goes wrong. I actually did that on purpose. So I've done that as an exercise so that later you come to me in office hours and you tell me what's wrong with that. OK, let's move on. The next thing I want to show you is a quick overview also on terms of annotation classes. Here we've added some additional things for support for enums. For example, I can have enums in my annotation. I can have nested annotations. I can have properties as part of my companion object. So again, this gives me more expressiveness in when I'm using the actual annotations. Now, there's one other thing that we've been working on, which you may have heard about, which is multi-platform programming. And the idea behind multi-platform programming, which is a mouthful, is the idea that right now Kotlin allows you to target different types of platforms. So I can target the JVM, I can target JavaScript, I can target native, etc. Now, one of the great things about this is the ability to be able to share code, because there's a lot of code that I want to end up sharing, right? There's business logic, there's validation logic, etc., that I want to end up sharing. So how do we kind of do this? This is where we've introduced the concept of multi-platform programming, and as a consequence of that, you now have the idea of having this multi-platform project. So you can see here that I've got this project in my IDE, and I'm targeting different kinds of platforms. So I have macOS, I have JVM, and I have JavaScript. And then I have a series of common code, which is called common. And inside here, I have some code. So here I have this function called hello that is saying hello from platform.name. And platform.name is a property of object. But the difference is that this object has this word in front of it, which is called expect. So what this is saying is that this is some code that I can reference in my common code, but the implementation is not actually provided here. The implementation is going to be provided on different types of platforms in a different way, because it can vary based on the platform. So you can see that it's got this cute little A in the corner here, and if we hit Alt-Enter, when we say go to declaration, it asks me which platform declaration do I want to go to. So if I say JVM, it will take me to the JVM one. If I go back and I say go to actual declaration on Mac OS, it will take me to the Mac OS one, right? So for different platforms, I can have different implementations, and yet I can reference that code in my common code and use it as part of my shared code base. And a cool thing, so kind of like think of it as a little bit like interfaces and then the implementation of those interfaces. And the cool thing is that you get the static compile time checking, so to speak. So if I were to comment this out and I go back here, you can see that it's giving me an error saying that one of the actual platforms is missing an implementation. So this is allowing you to now create multi-platform projects that allow you to share common code base and then have specific implementations based on the actual target a little bit differently. Okay? And that's part of the multi-platform project that we are offering moving forward with Kotlin, allowing you to, for example, create Android applications that share common code base with Android, iOS, etc. And if we can switch back to slides, I will talk to you a little bit about some of the other things that we've been bringing to Kotlin, the language. We have more standard library APIs. We're still keeping the API numbers of methods calls kind of low, but we're adding a lot more functionality in that area. Support for unsigned integers. Anybody? No? Yes. I just added that because I know someone always claps about that. Obviously, we announced back at Kotlin Conf in 2018 that Kotlin Native has hit beta. In terms of tooling, we've provided improved performance speed, parallel builds for Gradle projects, incremental annotation processing with capped, and a shout out to Ivan Gavrilok from Google for helping us with that. New type inference engine, which helps in a lot of cases in interoperability, especially if you're doing things around RX, as well as making the language a little bit more concise when you're using builders, etc. And we've introduced this progressive mode, which is essentially allowing you to try out Kotlin, try out new features, even if those features will actually break some code. So that's a flag that you can now enable with Kotlin to kind of live a little bit more on the edge. And with that, I'll hand it off to Jeffrey that's going to show you some other things that we've been doing in Android specifically.
Thanks, Hadi. I think there is one feature that you forgot to demo.
I have no idea what you're talking about.
It's OK, I'll show it in my demo.
You probably broke it.
OK, so let's take a look at what we have done in the Android side to support Kotlin. So let's first start with the OS. Of course, the OS works on bytecode, so there's not a lot we need to do to support Kotlin. But we did make sure that we added correctness and performance tests so that we don't break Kotlin patterns. We implemented a couple specific performance optimizations based on those tests, specifically for loop optimizations. And then the big thing we did on the OS side is improve debugging support. Kotlin has a couple of constructs like inline functions that you don't have in other languages. And so the new versions of Android now support debugging that better. Then next up, the Android frameworks. There's a lot of things that happened there. The big thing is that we added API annotations. That's not complete yet, but any new API, we now have nullness and default parameter, default value annotations, so you can use those from Kotlin. And we're working through the existing API to annotate that as well. Then we added these Kotlin extension APIs. So these are extra libraries that you include in your project that provide extra APIs through extension methods that make your Kotlin code more idiomatic. Then we added coroutine support for a whole bunch of the Jetpack libraries. So this allows you to write asynchronous code in a more procedural way. And of course, yesterday we announced Jetpack Compose, which is all Kotlin. So let's take a look at the demo. OK, so I've built a small app here. It downloads a list of shows that are available from a server using retrofit. And then it checks against the local SQL database if I've watched these shows using the Room APIs. So here you see that I have defined the API to get the list of shows in both using RX Java as well as using the Kotlin coroutine async feature. And you see that the APIs are pretty much the same with like just a little different return type. In the room side, oh, sorry. Oops. Where did my code go? OK, we'll skip the API. It's pretty much, oh, here it is, sorry. So you see the same thing. Have I watched the show? Rx in Java, it's very similar. Here's a flowable, there's a suspend. So the API is pretty similar. Now let's look at the you call that code between Rx and Java, Rx and coroutines. So in Rx, we use a lot of operators to do our flow with all the asynchronous calls. And these can become pretty complex. And you see that this code is highlighted yellow. It means that there's something I'm not doing with the return type. So you need to make sure that when you subscribe, you deal with the subscription. Of course, Rx brought great expressibility to Java. And the inventors of Rx, they were smart. They knew what they were building. But they were limited by the language. In Kotlin, we now have coroutines. And we can actually do this much nicer. So here is the same code using coroutines. We first get the list of shows from the server. And then we call this await function. And the IDE tells you, hey, there's something asynchronous going on here. Then we can use regular for loops and iterate over the return shows. And then we make our asynchronous call to see if I have watched this show in the local database. And then we continue from there. And then here you see this launch call, which will tell you, hey, make this call to make sure that we notify that the data set is changed on the UI thread. And so the nice thing here is that it looks more procedural. And when I do my debugging, which I'll launch now. There we go. And that's not working, of course. Oh, there we go. It's already run. So you see that I can actually look at variables from the whole method, not just from the specific operator. And so it makes your life much easier when you're debugging your asynchronous code. So let's switch back to the slides. OK, so next, Android tooling. We have done a lot of stuff in Android Studio to make sure that Kotlin is supported well. The first thing we did is we made sure that the Kotlin plugin is part of Android Studio so that we can test it well before we release it. And we also work closely with JetBrains. Anytime they update the Kotlin plugin, we test it before they go public to make sure that Android Studio and Kotlin work well together. Next, we added Android-specific refactoring support. There's a lot of actions in the IDE that are Android-specific refactorings, and we're working on adding support for all of those in Kotlin. On the lint side, lint has pretty much completely been rewritten. It used to write static analysis checks for Java language. Now it uses this thing called UAST, which allows you to write the same lint check once, and then it can analyze both Kotlin and Java code. We added project templates so that when you're creating a new fragment or a new activity, you have Kotlin code right in the start. You don't have to convert that. Then on the compiler side, our new shrinker, R8, has a lot of Kotlin-specific optimization in it so that you get the benefit of making your code as small as possible. And of course, the IDE has now support for the Jetpack Compose framework. On the documentation and sample side, if you look at developers.android.com, all API references now have both Kotlin and Java syntax available. There is a Kotlin-specific documentation portal, which will tell you how to get started on Kotlin, how to use code routines, etc. You also see that a lot of the samples and snippets now have Kotlin available. That's both on the site, on our GitHub samples, as well as if you look on Google I/O this year, you'll see that most of the presentations on Android, there are samples in Kotlin. There's a couple of apps that you can take a look at as well. The Google I/O app, as well as this new Android Sunflower app, have been built up from the ground up using Kotlin. We often get asked, hey, it's great that you guys are recommending Kotlin, but are you using it yourself? And of course, that's a very fair question. Now at Google, we have a lot of in-house developer tools. And so it took us some time to add Kotlin support to those. We started out with internal apps for Googlers. For instance, there's an internal app that shows you maps and office locations. And so we learned a lot from that. And then since then, we have actually started using Kotlin in some of the public Google apps. And so here are some of the apps that are shipping Kotlin code on your phones today. And you can expect many more to follow. Talking about adopting Kotlin, if you look at the whole ecosystem, we've seen that in active development, and active development is apps that have had an upload to the Play Store in the last 6 months, we see that 16% of the apps are now using Kotlin. And keep in mind, an app can be updated just because there's one bug fix or one asset changed. So 16% is pretty impressive. That's 5 times growth since last I/O. And if you look at the top 1,000 apps, that's actually already a lot bigger. 44% of the apps there we see using Kotlin. So that brings us to Kotlin First. We announced that yesterday, and so I wanted to give you a bit more overview of why we did it and what it's going to mean. So why did we announce Kotlin First? We see strong adoption of people using Kotlin, and we see a big excitement in the community when people start using Kotlin. In fact, when people are asked in our surveys on how much happier they're using Kotlin, they actually score 25% higher than people who are not using Kotlin. Many apps across the industry and inside Google are now using Kotlin. We reached out to many of our customers, including our customer advisory board, and they're like, keep focused on investment in Kotlin. So what does that mean? Of course, we're going to keep supporting the Java programming language in many aspects, right? Platform, Android Studio support, Lint, like Docs, Android X. That's not going away. But if you look at some other efforts, like our online training, samples, we'll first do Kotlin, and then Java programming language will be best effort. And then, of course, there are some features, like the Multiplatform projects and Jetpack Compose, that are only going to be offered in Kotlin. Now, of course, the next question that we hear from people is, well, does that mean I should switch? Please don't take Kotlin first as I need to go take all my Java code and rewrite it in Kotlin. That's not what we want you to do. Like, look at Android Studio. That is many, many 100,000 lines of code. Right now, we're about 10% Kotlin of the Android Studio specific code. And so what we do is we only take new functionality, write that in Kotlin. And that is possible because Kotlin has great interoperability with Java. You can write a single class in Kotlin and keep the rest in Java, or have 99% of your code in Kotlin and have only some leftovers in Java. Of course, it matters what is your current state of your project and team. If you're 1 week away from shipping your release, probably not the best time to switch to Kotlin. But if you're starting a new development cycle and you're like, hey, I could probably take on Kotlin. And of course, it depends on your team as well. Are they interested in Kotlin? Do they feel secure taking this on? We have also found that a lot of people actually use mentioning Kotlin in their recruitment, that they can get a lot more candidates. So things to consider. Of course, on the technical side, there's also trade-offs to consider. Kotlin brings great features, a lot more productivity and satisfaction. But you have to think about the learning curve. It takes time for people to learn to write idiomatic Kotlin. We see that most people who start writing Kotlin the first week, they're really writing Java in Kotlin. And it takes them 3 to 6 months to really start writing idiomatic Kotlin. That's fine. I mean, you still get all the benefits of Kotlin warning you about nullness, etc. Then there's the build speed. Kotlin is slower than the Java compiler. It's doing more work for you, and it's a younger compiler. We are working hard on making it faster. And of course, keep in mind, yes, it's slower, but you have to do fewer builds because your app will most likely be correcter. And there's also the APK size. The app uses standard library, and it takes some space. But things like R8 can help you reduce that. There's a whole bunch of ongoing Kotlin work going on at Google. Of course, Jetpack Compose is the biggest thing there. We'll always keep adding new KDX APIs all the time. And then on the compiler side, we're doing a lot of work to make it faster. And like with Kotlin 1.3.30, we added incrementation processors, and there's much more to come. You'll see more improved tooling and more docs and samples using Kotlin. If you're interested in using Kotlin, but you're not sure where to start, we are announcing Kotlin Everywhere, which is a set of trainings hosted by both Google and JetBrains. And it's happening between now and Kotlin Conf at December at the end of the year. If you're interested in that, either participating or helping hosting it, go to this link and sign up. So with our new Kotlin First roadmap, the investments in Kotlin for Android is only going to become larger. I'd like to invite all of you who haven't tried Kotlin yet or haven't recently used it to try it in your app today. I hope you'll have a similar experience like me with Kotlin. You'll be more productive and have more fun coding. Thank you very much.